Okay, so what we're going to do today is a day 2 of this 7.1. And so if you guys remember from yesterday, we talked about 2 different ways to find area. Do y'all remember why we had to have a second way? Like we started off doing top curve minus bottom curve, but why did that not work in this example 2? It was going to make it more complicated because we were going to have to break it up into 2 pieces. And so there, and plus, if you look at these equations, there's a y squared in one of them. That's really your biggest indicator that you're going to, this is a with respect to y. And that was a brand new thing. We hadn't done that before, okay? And so instead of doing top curve minus bottom curve, it was right curve minus left curve. And then this was your homework, which I'm sure all of you did every little bit of last night, right?
Yes.
Okay, so, and then we did that example 1, and so what we're going to do right now is go ahead and do this example 2, so if you turn that page, we got to graph this, and we got to determine if this should be with respect to y or with respect to x. You may already know, okay? Anybody think they do know which one this is with respect to? So we got 1x, we got 1y, we got some I'm not sure's. So if you're not sure by looking at the equation, then you need to start graphing. I am going to tell you how you can look at the equations and know, but it's really obvious once you start the graph. Okay, do you guys know how to graph x plus y squared equals 2? You might not remember. It's going to come back to you. But what can you always do with the graph? Lot points, and it's probably on this going to be easiest to say get x by itself. Okay, because if I try to get y by itself, then I'm going to have square roots, and that's going to be complicated. So when I let y be 0, 2 minus 0 squared is 2, that's going to give me the point 2 comma 0 as part of this graph. And I'm just going to keep going from there. Okay, what about when y equals 1? What would x equal? It's 2 minus 1 squared. 1, so 1, 1. Okay, also, if I had plugged in negative 1 in for y, I would also get x equals 1. So x equals 1, y equals negative 1 is another point. Do you see what shape this is going to make? If you don't, we got to just keep plotting points. Okay, what about when y equals 2? 2 squared is 4, 2 minus 2 is negative 2. So when y equals 2, x should be negative 2. So that's the point negative 2, 2. It's also going to work out with negative 2, negative 2. What shape did we just make? A parabola, except a horizontal parabola. Do you guys remember learning about conic sections? Okay, if you have an x squared and a y squared, that's a circle. It could mean ellipse or hyperbola depending on what the numbers, but in this class, if you see an x squared and a y squared, it's going to be a circle. If you see an x that's not squared and a y that is squared, it's a horizontal parabola. And then, of course, you're used to the x squared being just a regular parabola. Okay? When you have this horizontal parabola, you are going to be with respect to y. You can even see it now in the equation that I've written. See the equation, how it's in terms of y? The body of that equation is 2 minus y squared. That means this is going to be a with respect to y. So you're going to start to pick up on this more as we kind of practice. Okay, what about y plus x equals 0? What shape does that make? It's a line. We're probably more used to solving for y, and y equals negative x. We could solve for x and get x equals negative y. Okay, I wrote it this way because if I'm going to be with respect to y, or in terms of y, I need to have both equations. Write this down in your notes. Need to be x equals blah, blah, blah with a y somewhere in there. Okay? when you determine that it's with respect to y, you have to have your equations as x equals instead of y equals. Okay, so let's go ahead and graph this line. You could do this by using slope. You could do it by just plotting points. And be as neat as you could possibly be, because if you are neat, then what you notice is you have some intersection points that are happening at integers, at whole numbers. Okay, so this little piece right here on the inside is what we're trying to find the area of. All right, so if you were like, I still don't get why this is with respect to y. Okay, here's your biggest clue. There is no top curve and bottom curve. Well, there is, except the bottom curve changes. Okay, but I do see a right and a left. Okay, so the right curve is this 2 minus y squared, and the left curve is negative y. Okay, so what we're going to do is we're going to integrate right minus left. And we talked about this is all on the first page. What about my limits of integration, my bounds? Those used to be left and right. So what are they now? Everything's switched. Bottom and top. This is going to be the bottom. This is going to be the top. And they're y values. So what is the y value at the bottom? Negative 1. And the y value at the top is y equals 2. Okay, so my area is going to be the integral from negative 1 to 2. Okay, and I'm going to go ahead and draw the approximating rectangle on this. This is only going to help some people. Some people, this doesn't really help them. They don't need this. But if you're, I don't know, just for maybe one or two of you in here, I think this really helps you understand why this works. If we're going to integrate from bottom to top, what we're doing is we're finding the area of this little skinny rectangle, and then we're adding them all up. And the width of that rectangle, okay, is going to be the right curve minus the left curve. Okay, for those of you that are more like, you just like rules, or you're more analytical than you are visual, notice that everything is in terms of y. The bounds are the y values. The functions here are, or the expressions are in terms of y. And we have a dy. Everything is in y and not x. All right, so this is an even, so that means you get to use your calculator on this, which is good. When you get to use your calculator, you want to. You don't want to be stuck on a problem like this, not with the calculator or not knowing how to use it, because it's going to take you a lot longer. You're going to have to then do it by hand. So I'm going to do 2 minus y squared minus parenthesis negative y, close parenthesis, comma y, comma negative 1, comma 2. Okay. My answer should be positive. We talked about this yesterday. Area should always be positive. A single integral might be negative, but an area is always going to be positive. So if you accidentally get negative 9 over 2, then that means that probably that you either mixed up these two things or you mixed up your bounds there. All right, that's easy to fix though. Easy to happen, easy to fix. Okay, and of course you could write 4.5. Okay, any questions on this before we do one more problem? Yeah.
Could you explain again? I think you must have missed it. How you got to have that equation for the integral that you plugged in? You had it's the equation for the two.
You take, yeah, you take that and you subtract this.
Okay, and that's for everything.
That's what you do when it's with respect to y, and when it's with respect to x, you would do the top curve minus the bottom curve. So here we did 9 minus x squared minus x plus 1, and that was with respect to x. We're going to do another with respect to x problem here in a minute. Okay, so turn the page. This is supposed to be a non-calculator problem, but we're going to really use, I want to do this one because there's a lot of ways the calculator will really help us, and this is a good problem to use it on. Okay, so first off, how do you feel about graphing a cubit? I'm going to take that as not great, which means, well, then we got to plug in numbers. Okay, so like we gotta say, okay, plug in a 0 and we get 3, right? What happens when you plug in 1? 1 minus 5 plus 3, that would be -1. And we could continue, right? Maybe we don't want to, but we could. Okay, I'm going to show you, if you get to use a calculator, you don't really have to go through all of that. Go into your y equals, and let's just go ahead and type in these two. I already have this typed in from my previous class. Okay, the line, I think you're going to have no problem typing in. And remember, your calculator will only do this for y equals. It won't do this for x equals. So that even tells us which with respect to is this problem. Look at your equations right here. What are they in terms of? X. This is a with respect to x problem. If you wanted to make it somehow into a with respect to y, you would have to get x by itself, which would be really tough to do on this problem. You can actually force any problem to be one or the other. It's just, there's always one that's a lot easier. Okay, so I plugged all that in, and now you could set your window a variety of ways. I'm just going to do F2.6, just their standard window. And I see a cubic, that looks like a cubic, so that's a good sign, and then this looks like a line, so that's good. And so from here, you could trace F3, you could say trace to 2, okay, and you get 1. I'm going to have to just keep doing this. Okay, you could trace to 3, you get 15, so I'm not going to plot that point. I could trace with -1 and get 7. How else could I look up these values? The table. So it's really whatever floats your boat here, okay? So this is what the cubic looks like, and I'll bring the calculator up in a minute if you need to see it again, but we need to kind of just graph the basic shape. The line, hopefully you do not need your calculator to graph this line. And, oh, it doesn't look like they're lining up perfectly like some of the other problems. Like this would be a lot better of a problem if this was just -x and not -1/2. Okay? So a couple of things to notice here. I have 2 different regions. Okay? That's not that bad. That means I'm just going to do 2 problems. Unless I notice something. I mean, if you notice something interesting, feel free to shout it out. Okay? I don't know, though, like, what these points are. So again, this is how your calculator could help you. If you go to F5 and you go to intersection, okay, and I want to find this. See, it says first curve, press enter, second curve, press enter. But when it says lower bound, just skip your calculator to the left of that intersection. Press enter, then skip your calculator over to the right of that intersection, press enter. And remember, we're with respect to x. I do not care for the y value at all. I don't care. It's not going to help me. I'm not going to use it in my problem, so I only care about this x value over here. And so I'm going to write it out, -2.12132. Okay, and then we're going to come over here to the right, and we're going to do it again. F5, 5 for intersection. Again, you can go enter, enter. When you see this left bound and right bound, you need to be just barely to the left of that intersection, and then when it says upper bound, go to the right. Enter. And something interesting, I get the exact same number, except it's positive. What does that tell me about this graph? Just anything you notice.
Symmetrical.
It's very symmetrical. So if you had to guess, how would you guess these 2 areas are related? They are going to be the same. So, well, no, they're both going to be positive. They're both going to be positive. So if you have pretty high confidence that they're the same, then really we only need to find one and double it. But if you didn't catch that, you would have to do this in 2 separate pieces, okay? But we did notice it, so our area is going to be 2. Now remember, this is with respect to x. And so I'm going to choose this one, okay? and I'm going to just double this one. We could have chose the one up here. It doesn't matter because they're the same. And if you weren't sure they're the same, you would do both of them and add them up. So our integration is going to be from 0 to 2.12132. Our top curve, I didn't label it on this, I should have, is the line. This one's the top, this one's the bottom for this piece. Now it switches over here on this piece. But don't get too caught up on which one's the top, which one's the bottom. Because if you get them switched up, the only thing it's going to do is give you a negative answer. Okay? Are we feeling a little bit better about this stuff? The hardest part is going to be sketching the graph. Okay? Use your calculator to help you as needed, but really try to do as much of it as you can without your calculator. Okay? You're going to get to use your calculator on most of it, but not all of it. Okay, I'm going to leave you to that one. So your homework is that book assignment from yesterday that I assigned, and then finishing out this worksheet. So some people were like, oh, that means 4 and 5, and I said, no, it means finish the worksheet. I get that this is a lot of problems, but it means all the way through number 14 here. This is not due Monday, this is due Tuesday. However, I am going to be taking questions on this on Monday. You are only helping yourself if you get as much of this done as you can. Okay? And so finishing this week,